Okay, last one because I've only done 3 practice tests so far. And I'm getting tired. Yeah, I still don't know my ID. Smiley face. Let's do this. Consider the vector field potential function. This weird thing. Okay, so we gotta first find the integral of the f term x. So that'll be ex. Whoops, I should probably just write it out. E to the power of xz minus y sine of xy. So that produces x times e power of yz minus, in this case, you gotta do u equals xy and du equals y. So you get, so that y cancels out, and you just get plus cosine of, I'm just gonna keep it as xy because I want to, plus a of xy. Sweet. Okay, so now we gotta take the derivative at y, which means you get xz, because this comes down, e to the yz plus, oh whoops, that's gotta be negative. That'll be minus, you gotta take this derivative, x of sine of xy plus a prime of, I'm sorry guys, that'll be yz. yz. Sweet. Okay, so now you set all of this equal to g. So g is equal to xz, I'm sorry, whoops, zx eyz minus x sine of xy. If you notice, in this case, if you do this minus the g, you'll just get a prime of y of z equals 0. So you stop here, which means that your potential function would just be x times e to the power of yz plus cosine of xy. And that will always be plus to some constant, but in this case, that's not what the answer will show. Okay, second one. You got a triangle with these vertices, and it's counterclockwise. So let's actually draw this out right now, right? So we'll have our first point at 0, 0, our next point at 2, 0, and our third point at 1, 1. So it'll be this thing here, counterclockwise. So we have to set up a line integral. Or to do that, we have to tap into the hidden power of Green's theorem. So Green's theorem, we got to find the curl, which is just the partial derivative of x at g minus the partial derivative of y at x. So we have this right here. So that'll be, this is essentially our f dx, and this is our g dy. Remember that. So in this case, g of x would just be e to the power of x, and cosine cosine cubed of x, partial derivative of y, would just be 0. So you just get e to the power of x. So now is when we actually have to do something very strange. We have to set up 2 double integrals, because as you can see, as you move along this curve, your y bounds will change. So if I redraw it here, I'm going to put a line right there. We're going to call this part 1 and call this part 2. Sweet. Okay. So as you can see right here, this is 1, 1. As you can see, we're going to call this part 1 right here. Y goes from 0 right here, and it goes up to x, because this is 0, 0, which means that this is y equals to x. That's our first one, and then for this one, x simply goes from 0 to 1. So ex dy dx. Sweet. So that'll be plus our second one, which is part 2. Call this part 2. And that'll be, so now y is from 0, but that'll be 2 minus x, because if you extend this out or all the way over here, because there's technically like the invisible line right there, it'll be a y-intercept at 2, and the slope is still x. So that becomes y equals 2 minus x, 0, 2, and the x is now from 1 to 2. Ex dy dx. Okay, so now we have to do like a whole lot of math. So if we first do dy for this one, let's solve part 1. 0 to 1, 0 to x, ey dy dx. So if you do dy, you get ey times ex from 0 to x. You get x ex, 0 to 1. Now you have to do partial integration. I mean, not partial integration. Integrate by parts. So in this case, I'll set my u equal to x. So my du is just 1. And my dv is e to the power of x, which means my v is just ex. So uv minus the integral of v du, which is just x ex minus the integral of ex du, which is just 1. Which means you just get, well, I guess in this case it's dx, but 1 dx. So in this case, you get x times ex minus just ex. That's from 0 to 1. So in this case, 0 to 1, you just get 1 e. So I guess it's just, oh, my thing is so big. You just get e minus e, which is minus 2, 0 minus e, 0. So you get 0 minus negative 1, which is just equal to 1. That's our part 1, by the way, right there. So let's move on to part 2. Part 2, you'll be the same rundown. 0 to 2 minus x. Why did I write it like that? That's so weird. So you get 2 minus x e to the power of x, which is just equal to 2e minus x e to the power of x. That'd be from 1 to 2, 2e minus x e to the power of x. So now you can split these up. This becomes the integral of 2xe from 1 to 2. And this becomes the integral of x ex minus ex from 1 to 2. So in this case, you'll get 2e minus, sorry, not 2e. You'll get, am I tripping? Ex minus 2ex. Oh, that should be 2ex. Whoops. 2ex. And that doesn't really change because it just stays like that. So now I got 2e squared minus 2e, which is all minus this, which becomes 2e squared minus e squared minus e minus e, which is equal to 2e squared minus 2e minus 2e squared minus e squared, which is equal to 2e squared minus 2e minus e squared, which is just equal to e squared minus 2e, which is correct. So now we got to add these two together. So you get e squared minus 2e plus 1, which is our final answer. And the answer for this one is 2e squared minus 2e plus 1, which is e, and that's our answer. Yes, that's an incredibly long question and a very real question. Have fun. Okay, so now we want to find the curl. So the curl, when it's 3 dimensions, if you don't have them memorized, I'll show you how to have them memorized now. So you want to set up your thing like this with f, g, h. So in this case, you get h of h minus g of z minus, that's your I. So I guess if you were really doing it, it would be d over dx, d over dy, d over dz. So it would be the partials. But I write it out like this just because that's how I remembered it. But if you want to do it like the more formal way, then go right ahead. So this will be h of x minus f of z j plus, it's just regular cross product, g of x minus f of y. So in that case, you get h of y is equal to g of z, minus g of z. Okay, so you set that up, and that's very cool. So now we gotta plug these in. These are HGF. So h of y would be equal to negative sine of y minus g of z, which is cosine of z. Okay, so that's our first one. So just by looking at that one, we actually know it can't be this, it can't be this, it's not this. So now we have to find what this could be, because these are both zeros. So let's just ignore this in general. G of x minus f of y. So g of x is 0, f of y, so f is equal to xy, which means the partial derivative of x would just be equal to x. So that would just be g of x 0 minus x. So your k would just be negative x. This one is negative x. The answer is C. Sweet. Find the volume of the solid under the plane z equals 2x above the region R in the first quadrant of the xy plane bounded by the coordinates x plus y equals 1. So how I would find this out is first find your bounds. So xy equals 1. I would just say y is equal to 1 minus x. So 0 less than y less than 1 minus x. So just is equal to 1, because once you set that to 0, x is just equal to 1. Sweet. So now that you have your bounds, you just set it up. 0, 1 minus x, 0, 1. Z is equal to 2x in this case, so it would be dy dx. Sweet. Okay, so to find dx, you get 2zy, 0, 1 minus x, which is equal to 2x, 1 minus x. So you get 2x minus 2x squared. And once you do that, 0 to 1, 2x minus 2x squared dx is just equal to x squared minus 2 over 3 x cubed. So from 0 to 1, so you get 1 minus 2/3, which is equal to just 1/3. And 1/3 is your answer. Yep. Okay, evaluate this integral. Okay, we're gonna have fun with this one. That seems like a long one. Okay. Okay. So in this case, 2y ex dz. That'd be z ex from 0 to 2 minus y. Pretty simple integration here. You just get 2 minus y ex in this case. So if you really wanted to, what I'm going to do, I'm going to take the ex out, because the next one, the chop. Oh, wait, no, I can't do that. I'm going to take the 2 minus y out, because the next one in the chopping block is just e of x. So e of x from 0 to 1 is just equal to ex 0, 1, which is equal to e minus e0, which is equal to e minus 1. So if you wanted to, you can now do, you can take the e out, and then do 0, 1, 2 minus y, which is equal to 2y minus 2y y squared over 2, 0 to 1 is equal to 2 minus 1/2, which is just equal to, I'm being dumb, 3 over 2. So once you get that, 3 over 2 times e minus 1, that's your answer, C. Pretty simple stuff, actually. Okay, the volume of the region inside this sphere, this cone, is given by this. So we just want to find A, B, and C. Okay, so remember, for C, it should always be rho squared sine of this. So it can't be this because there's a cosine. It can't be this, there's a cosine, and the rest of these ones check out. Cool. So now what we're going to do is we're going to try to find our rho. So we know that rho squared is equal to x squared plus y squared plus z squared, which is also equal to 4. So the rho is equal to 2. So can't be e. Sorry, just going to take those out. Can't be e. So now we have to find our phi, which is so fun, but it's also basically given to us right here. So same orderly process. We're going to just square both sides. So we know that phi, rho squared cosine squared of phi is equal to 3 rho squared. I'm going to move this over here. So you go to 3 rho sine squared of phi cosine of theta plus 3 phi squared sine squared of phi sine theta. So basically we know that 3 rho squared sine squared of theta is equal, because I forgot to put the square there somehow. Okay, but anyways, once you add those two up, it's just 1 is equal to rho squared cosine squared of phi. We can just take those rows away, and thus we get sine squared of phi over cosine squared of phi is actually just equal to 1/3. Yes, it's just equal to 1/3. So we know that the tangent phi is equal to 1/3. So usually it's 1, so we just know it's pi over 2. But since it's 1/3, now we have to solve a few. But if you remember, you would know, if you remember your unit circle, you would know that at pi over 6, we get the coordinate 1/2, and so if we do that, sine over cosine just gets square root of 3 over 2 times 2 over 1, which just gets us square root of 3. We square that because it's tangent of phi, and thus our phi is just equal to, wait, I'm stupid. Sorry, it's sine over cosine, so, oh wait, that's not pi over 6, whoops, my bad, my bad, guys. If you have pi over 6, it's square root of 3 over 2, 1/2. My bad. Okay, so you get 1 over 2 times 2 square root of 3, so you get 1 over square root of 3, which translates to square root of 3 over 3. You square that, you get 3 over 9, which equals to 1/2. So these check out, and thus we know that phi is equal to pi over 6, which is why the answer is D. Yay! Okay. This is another Lagrange, I don't know why I said it like that, Lagrange multipliers question. Okay, so if we take the gradient at f, we get, oh man, this is going to be weird, 2x minus 2 times 1, and then 2y minus 4, 1, which just turns out to 2x minus 4, and 2y minus 8. Cool. And the gradient at g is just 2x, 2y. Cool. So we know that 2x minus 4 is equal to lambda 2x. Then we know 2y minus 8 is equal to lambda 2y, which is cool. So in this case, what I would do is I would say 2x minus 4 over 2x is equal to lambda. Lambda is also equal to 2y minus 8 over 2y. So you set those equal to each other. 2x minus 4 over 2x is equal to 2y minus 8 over 2y, which means you get 2x minus 4 times 2y is equal to 2x times 2y minus 8. So in that case, cancel out those. Wait, no, that's not how math works. I done goof something up. Wait a second, sorry. Let's take a different approach. So if we divide all this by 2, you get x minus 2 is equal to lambda x. So we know that lambda is equal to x minus 2 over x. So I'm going to plug this into here. So 2y minus 8 is equal to x minus 2 over x, 2y, which means that 2y minus 8 is equal to that. Wait, no, I don't want to do that either. That's going to take too much time. We can do the same thing here. So y minus 4 is equal to lambda y, which means that lambda is equal to y minus 4 over y. So y minus 4 over y is equal to x minus 2 over x, which gets you the values of xy minus 4, x is equal to xy minus 2y. So these cancel out. So you know that y is equal to 2x. There we go. Sorry, that took a while. Okay. So you know your g is equal to x squared plus y squared equal to 5. So if you plug this in, x squared plus 2x squared equals 5. So x squared plus 4x squared equals 5. 5x squared equals 5. So x is equal to plus or minus 1. So now we have to test these points out again. X equals negative 1, you get 1 plus y squared equals 5. Y squared equals 4. So y equals plus or minus 2. So you get your critical points at negative 1, 2, negative 1, negative 2. At x equals 1, you get the same thing. Y equals plus or minus 2 because it's just the square root. Sorry, because that's just the square root. So your critical points are 1, 2, negative 1. Sorry, not negative 1. 1, negative 2. So now that we have our 4 critical points, we gotta test that in here, which is x minus 2 squared plus y minus 4 squared. Okay, so let's test out negative 1, 2, which gets us negative 1 minus 2, negative 3 squared plus 2 minus 4, which is negative 2 squared. That gets us 9 plus 4 equals 13. Oh, what the heck? Okay, and then if we test out -1, -2, you get -1 minus 2, -3 squared, plus -2 minus 4, -6 squared. You get 9 plus 36 equals 45. F of 1, 2 is just 1 minus 2, -1 squared, plus 2 minus 4, -2 squared, just equals to 1 plus 4 equals to 5. F of 1, -2 is equal to -1 squared, plus -6 squared is equal to 1 plus 36 equal to 37. Whoopsie daisy. So if we want to find our max and our min, that's our max. 5 is our min, which means the answer is A, 45 and 5. Okay, compute this, change the order of integration. Cool. So we know that y less than x less than 1. 0 less than y less than 1. So if we pop this out over here, look like this, x equal to y, and then x equals to 1, 0, y equals to 1. So it would be like in here. So if we change the order of integration, you would just get y is now equal to x. So now y goes from 0 to x, while x goes from 0 to 1. So 0, 1, 0, x of ex squared dx dy. Sweet. Now we just have to evaluate. So this just becomes, let me pull the ex out there. My bad. Let me just pull the e to the power of x squared out there. Y, that would be 0x, which is equals to x, ex squared. So now we have to do 0 to 1 of x, ex squared. I was tempted to do integration by parts, but you can actually just do a u substitution since d is equal to 2x. So you just get 1/2 of e to the u. And this just becomes 1. And this just becomes 0 still. So just get 1/2 e to the 1 to the power of 1 minus e0, which just gets you 1/2 e minus 1, which is this answer right here. Okay, number 9. Compute this, where it is the region surrounded by this. Okay, so this is a polar coordinate. We know that x squared plus y squared equals r squared, so r squared equals 4. R is equal to 2. Just set that up right there. There's a circle, so from 0 to 2 pi. So that would be e negative r squared r dr d theta. Sweet. That was quick. My bad. And then r e negative r squared from 0 to 2 would be around, we got to do u substitution, u equals negative r squared, du equals negative 2r. So in this case, we're going to do negative 1/2 e to the u. So our bounds would change to look like negative 4, since you plug in the 2, and 0. So you get negative 4, 0. But since we don't really like that, we can switch it up. And now you have negative 4 to 0, and this goes away. 1/2 EU, so you just get EU negative 4 to 0. Just get E0 minus e to the negative 4th equals 1 minus e to the negative 4th. Yeah. And the 1/2 is still there. But we don't have to worry about that right now. So the second one is the theta. So 0 to 2 pi I'm going to keep the 1/2 out there. 1 minus e to the negative 4 is just equal to theta minus e theta negative 4, 0 to 2 pi, which equals to 2 pi minus 2 pi e to the negative 4th. You plug the 1/2 back in there, you get pi minus pi e to the negative 4th, which means that in this case, if you take out the pi, you get 1 minus e to the negative 4th, which is our answer. Yes. There you go. Okay. Let a equals 0, let c be this curve. Okay. I would asterisk this question. It's very good. It's a very good concept question. All you need to know is that you have this curve here, and if you want to find the vector field that's orthogonal, which just means perpendicular around this curve. So imagine that you got this curve here, right? And you're at this point, and the tangent line's like right there. So your orthogonal point is right there. And what you should know is that in order to find the vector field of this, you simply have to find its gradient. So in this case, the gradient is equal to partial derivative at x, partial derivative at y, which is equals to 2x and negative 4y. So looking at our answers, that'd be answer B. So yeah, this is a good question to know. Highly recommend knowing this concept. Okay, compute this line integral of the function sine of 2 pi x plus xy along this curve that is parameterized, and they gave us the bounds. Wow, they're so nice. So let's first find r prime, which is 1 and 1. Now we got to find the magnitude, which is 1 squared plus 1 squared square root of 2. So that's our magnitude. And now we got to find f of r of t, which is equal to sine 2 pi t plus t squared because of that. So now we just, in order to find this, we gotta do f times the magnitude of r prime of t, which is equal to, I'm just gonna take this out for now, 0 to 1 sine 2 pi t plus t squared. So you can split this into two things now. Let's do the first one first. So if we do the u substitution, 2 prime t, that du is equal to 2 pi. So now we know 1 over 2 pi times 1 over 2 pi, and that'll be negative cosine of u. And if we plug in our values at 1, it would equal 2 pi. At 0, it would equal 0. So you got 2 pi, 0. So negative 1 over 2 pi cosine of u from 0 to 2 pi is simply equal to negative 1 over 2 pi cosine of 2 pi, which is just 1, minus, I guess plus in this case, 1 over 2 pi cosine of 0, which is also just 1. So you get negative 1 over 2 pi plus 1 over 2 pi. You go to 0. Quite disappointing, I must say. In this case, quite disappointing. And then in this case, you just get t squared is equal to t cubed over 3. T cubed over 3 from 0 to 1 is just equal to 1/3. Once you get the 1/3, you just gotta remember that this square root of 2 is still here, which gets our answer, square root of 2 over 3. which is indeed our answer. Sweet. Last one. Compute the flux. Okay, so flux is the vector f times the normal vector. Very good to know, okay? I'm going to show you a good trick to get the normal vector. So you first take r prime of t. So that would be negative 3 sine of t to 2 cosine of t. If you want to find the normal vector, change sign, flip. So the normal vector, this would become 3 sine t. So now, and then you flip, so you just get 3 sine t to cosine t. You just flip, you just change the sign of the thing right here, and then flip these two. So that's our normal vector. Sweet. Okay, so the f of r of t is just equal to 3 cosine t to sine of t. Pretty explanatory. I do f dot the normal vector, which is just 6 cosine squared of t plus 6 sine squared of t, which is equal to 6 in this case. So if we do it from negative pi to pi, you get 6 dt is equal to 6 pi minus negative 6 pi, which is equal to just 12 pi. In this case, our answer is in fact 12 pi. Oh, okay. So that was our last one. I hope you learned something. I am taking my calculus test in about a week, so this is also a good way for me to study. So, I hope you learned something.